In this video, we're going to look at an exam-style question using the Trapezium Rule. There we have the question on the left, and we also have the Trapezium Rule written out in full on the right. Okay, so let's look at this. For part 1, it says to use the Trapezium Rule with 5 ordinates or 4 strips. So that means that for the Trapezium Rule, the first thing we need to do is work out this thing h equals b minus a over n. Now h is the sort of the width of each strip, and b and a are the limits to the integral, so it's the 2 and the 0. So h is 2 minus 0, that's my b and a, over n. N is the number of strips, so n is just 4. 2 minus 0, 2 over 4 is 0.5. So this 0.5 is going to be the width of strips that we're using in our Trapezium Rule calculation. And to do a Trapezium Rule question, I usually create a little table of x values, y values. So let's do that. So here's my xi values. Now it says I'm using 5 ordinates, so I'm going to have x0, x1, x2, x3, and x4. That's my 5 ordinates. And what are these values of x? Well, my first one, x0, is where I start. It's my value of a. It's just 0. Then for x1, I'm just going to add h to that. So I'll just add 0.5. And I'm just going to keep adding h. So 1, add h again, 1.5. And add h one more time, 2. So then my values of x. And for each of these values of x, I need to create a y. A yi is just my function, in this case 6 to the x, applied to xi. So my yi in this case is 6 to the power of xi. So my y0 is 6 to the power of x0, which is 0. 6 to the power of 0 equals 1. y1 is 6 to the power of 0.5, which if you do that on your calculator, you get 2.449. Similarly, y2 is 6 to the power of 1, which is 6. y3 is 6 to the power of 1.5, which is 14.697. And y4 is 6 squared. 6 to the power of x4, 6 squared is 36. So now I've worked out all my y values, and I just have to plug these numbers into my Trapezium Rule at the top. So let's just plug the numbers in. My integral, I get the integral from 0 to 2 of 6 to the x is approximately equal to, it's half of h, so h is 0.5. And then I'm going to multiply all of this by y0 plus yn. So y0 is 1 and yn is 4, so y is our last value of y, which is 36. And then we want 2 lots of our other values. So we have 2 lots of 2.449 plus 6 plus 14.697. And that's it. That's our long calculation. We just need to be a bit careful with the brackets. So we work out 1 plus 36 and then add 2 times 2.449 plus 6 plus 14.697, multiplied by half and multiplied by our h, which is 0.5. If you do this big calculation, you get 20.823. The question asks for 3 significant figures. This is 20.8 to 3 significant figures. That's it. So you just need to be careful putting your y values into the Trapezium Rule formula. Okay, so that's part 1 done. Then the second part is explain with the aid of a diagram whether your approximate value will be an overestimate or an underestimate. So let's just remove what we've done so far and look at this. So for part 2, the important thing to note is that the shape of 6 to the x. And we're going between 0 and 2. And if we plot a graph of 6 to the x, y equals 6 to the x between 0 and 2, you get a curve that looks a bit like this. And this is a convex curve. And what that means is that if we had to approximate the area under this curve, so the area under the curve with trapezia, let's just have a look at one trapezium. So let's say the one that goes between, we had one between, let's say the one that went between 0.5 and 1. And if you draw this trapezium, the red line there is meant to be a straight line. Well, that straight line, because of the shape of the curve, that straight red line lies above the curve. So this area of the red trapezium is more than the area under the curve. If I also look at the trapezium between 1 and 1.5, we have the same thing. Again, a straight line between these 2 points will lie above the curve. So again, we have an overestimate. It's a little bit difficult for me to draw this accurately on the computer, but hopefully you get the idea and you'll be able to draw that more clearly on paper.